Welcome back everyone, Houston Math Prep here with our fourth and final video on solving exponential equations. We're doing exponential equations that are quadratic in form. So here, think about just a regular quadratic equation. We have something like x squared minus 7x plus 12 equals 0. And I've chosen something here that we would just normally solve by factoring. So we assume that your factoring is pretty solid whenever we're trying to solve something that is quadratic in form. What we would do here to factor these, we would look at something that multiplies to give us 12 and adds to get -7, and we would find those numbers are -3 and -4. We would put those in the factors, and then once we have factors multiplying to get 0, we would take each factor and set it equal to 0 and solve those equations. One of them is going to give us, when we add 3 to both sides, that x is 3, and when we add 4 to both sides in the other one, we'll get that x is equal to 4. When you solved quadratic equations before, you might have done it with different variables. This is the same problem, it's just with a in place of x. So I still ask myself the same question, what multiplies to get 12 and adds to get -7? And I say -3 and -4 just like before, only to get an a squared term, I would need a times a, and to get -7a, I would need -3a and -4a instead of -3x and -4x from my inside and my outside multiplication when I distribute. So we have our factors equal to 0, we set those factors equal to 0, we add 3 and we add 4, and we get answers of a equals 3 and a equals 4. But it is the same problem, we just have a different variable. We can do this no matter what we put into the equation. So here we have smiley face squared minus 7 times smiley face plus 12 equals 0. This is of the same form. It is quadratic in form. What we're asking here is what multiplies to get 12 and adds to get -7. We say -3 and -4, but what's going to go in the front of each factor is not x and it's not a, it's smiley face. So our factors are smiley face minus 3 times smiley face minus 4, and that equals to 0. I still have factors multiplying to get 0, so I set each factor equal to 0. That gives me smiley minus 3 equals 0 and smiley minus 4 equals 0. I add 3 and I add 4, and it ends up the same way. We get smiley equals 3 and smiley equals 4. But it's the same problem. What we put in, whether it's x or a or smiley face or a cat, we get 3 and we get 4 for our answers. Let's look at a similar equation now where we have exponentials in place of x or a or smiley face. Here I have 2 to the x squared minus 7 times 2 to the x plus 12 equals 0. What we want to see is that these 2 to the x expressions are simply in place of our smiley face. I have something squared minus 7 times that something plus 12 equals 0. I have something squared minus 7 times that something plus 12 equals 0. So I ask myself again, what multiplies to get 12 and what adds to get -7? And you should be feeling deja math because we've already asked you this 3 times. It is -3 and -4. What goes in the factor is whatever multiplies itself to get this first term. 2 to the x times 2 to the x gives us 2 to the x all squared, right? -3 2 to the x's minus 4 2 to the x's gives us -7 2 to the x's. Okay, just as sure as -3 smiley faces minus 4 more smiley faces gave us -7 smiley faces over here. So we get factors of 2 to the x minus 3 times 2 to the x minus 4. I take those factors since they're multiplying to get 0 and I set them equal to 0. Now I solve these a little bit differently. There's an extra step because it's 2 to the x in place of smiley face or a or x. I do add 3 to both sides, but then I have 2 to the x equals 3. What I need to do now to finish solving for x is undo the operation base 2 exponential. The opposite operation of base 2 exponential in math, remember, will be a log base 2. So we take the logarithm base 2 of both sides, and we get that x is equal to log base 2 of 3 for this one. We do a similar thing here. I'll need to get rid of the minus 4 over here to simplify to a single term, so I add 4 to both sides. I get 2 to the x is 4. I could take a log base 2 here, or I could just notice that 2 to some power gives me 4 is easy to solve by looking at it and get an answer of 2 in the end as well. Let's look at a few examples. We have 9 to the x minus 6 times 3 to the x plus 8 equals 0. We look at this first term and we have a different base than we do in the second term. So maybe it's hard for us to sort of see what we need to do when we're looking at this right away. So if you think about 9 to the x, and we want to get that in a form where it's maybe more friendly to us. So think about 9 as a power of 3. 9 is like having 3 squared, right, as a power of 3. So this is like 3 squared to the x. Well, I can multiply these, can't I? So that's the same as having 3 to the 2x. There's another thing that's the same as having 3 to the 2x, and that would be having 3 to the x all squared. This would be the same as 3 to the 2x, because I would multiply these and still get 2x. So this expression and this expression are the exact same thing. Whether the x is on the outside or the 2 is on the outside, this is the same thing, right? So really what we want to think of our 9 to the x as is 3 to the x all squared. Minus 6, I'll go ahead and put this 3 to the x in parentheses as well, plus 8 equal to 0. And now if we're doing just basic factoring here with a lead coefficient of 1, we say what multiplies to get 8 and adds to get negative 6. And our answer is going to be negative 2 and negative 4. Those will multiply to give me 8 and add to give me negative 6. So in the back of my factors, I will get minus 2 and I will get minus 4, and will be equal to 0. And what goes in the front of each factor, how do I get 3 to the x squared? Well, I'd need a 3 to the x times a 3 to the x. So these are our factors, 3 to the x minus 2 and 3 to the x minus 4. We now set each of those factors equal to 0, so we get 3 to the x minus 2 equals 0, and we get 3 to the x minus 4 equals 0. We'll go ahead and slide down here. So to get this 3 to the x by itself, we'll go ahead and add 2 to both sides. This will give me 3 to the x equals 2. And if I want to finish solving this, I need to undo the exponential base 3, which means I need to take a log 3 of both sides. We end up with x equal to log base 3 of 2 for this one. On the other side here, I would need to get rid of my minus 4 first, so I'll add 4 to both sides. That would leave 3 to the x by itself, and here I would just get positive 4. Changing this to log form, or taking log base 3 of both sides, would give us then x equals log base 3 of 4. Okay, so we get two answers there, log base 3 of 2 and log base 3 of 4. Looking at another one, 4 to the x minus 3 times 2 to the x minus 10 equals 0. We want to see this 4 to the x as 2 to the x squared, because 2 squared is 4. So we have 2 to the x squared minus 3 times 2 to the x minus 10 equals 0. And if these were smiley faces, we would have smiley face squared minus 3 smiley face minus 10. Factoring these, we would ask what multiplies to get negative 10 and adds to get negative 3. And the answers we come up with should be negative 5 and positive 2. So my factors will have a minus 5 and they will have a plus 2 in them. What goes in the front is whatever's being squared here if it's quadratic in form. So we get 2 to the x minus 5 and 2 to the x plus 2 equal to 0. Now if we set both of those equal to 0, we'll have 2 to the x minus 5 equals 0. We'll have 2 to the x plus 2 equals 0. For this first one, 2 to the x minus 5, I'll need to add 5 to both sides. And I will get 2 to the x equals 5. Writing this in log form, or taking log base 2 of both sides, however you think of it, will give you an answer of x equals log base 2 of 5. That's one of our answers. Looking over here, I would need to subtract 2 to get rid of the add 2 on both sides. So I get 2 to the x equals negative 2. And now you might have a little red flag going up in your mind that says, something is strange here, and you're right. If I try to get a negative number out of just a plain exponential, I shouldn't be able to do that, right? Another thing we can think of is if I change this to logarithm form, or take the log 2 of both sides, I will get that x equals log base 2 of negative 2. And we know that we cannot take logarithms of negative numbers, no matter what our base is. So this is actually not a good solution for this, and we only end up with one of our two possible answers checking out for us. Looking at one more, 25 to the x plus 3 times 5 to the x plus 2, we want to see this 25 as 5 squared. And so we will change our thought process here And think of this as 5 to the x squared plus 3 times 5 to the x plus 2 equals 0. Now, factoring this, I would think what multiplies to give positive 2 and adds to get 3, and if I think about it for a minute, I would get that the answers are 1 and 2. 1 times 2 is 2, and 1 plus 2 is 3. So in my factors, I will have a plus 1 and a plus 2. And what goes in the front of each factor, you can probably tell by looking at the b term and the a term here, is 5 to the x. So we get 5 to the x plus 1 times 5 to the x plus 2 equals 0. We said each of these factors equal to 0, just like we did before, so we get 5 to the x plus 1 equals 0, and we get 5 to the x plus 2 equals 0. Now, a funny thing happens for both of these. If I subtract 1 here, then I get an exponential equals a negative. And I know that's not okay. If I change it to logarithm form, take the log 5 of both sides, I get x equals log base 5 of negative 1, and that also tells me that's not okay. We can't take logs of negative numbers. We can only take logs of positive numbers. So that equation doesn't provide an answer for us. Over here, if I subtract 2, I'm still ending up with an exponential 5 to the x equals a negative number, and that's not going to work out either. If I change this to log form, or take the log 5 of both sides, I get that x is equal to log base 5 of negative 2. And again, logarithm of a negative number is no good. We can't do it. So both of our possible answers here do not check out. So that means that this has no real solution for this problem. We had two possible answers that we might have gotten, but neither one of them were any good, because we cannot take a logarithm of a negative number. So this one turns out not just one of our answers failed, but both of them failed. No real solution for this one. Okay, that's the wrap up of our 4-part series on solving exponential equations, solving quadratic and form equations here. Thanks for watching, everybody. Good luck with your exponential equation solving. We'll see you in a future video.